Okay, good afternoon guys, at least for me. Might be morning where you are, but that's completely fine. Just a couple of things here to get you started. I know that RT1 was kind of good, kind of bad, all of that tied together. You got some good information out of there. A lot of that was my fault. I had a lot of stuff going on and I thought I had more content in RT1, but apparently I didn't, so no worries. We'll get you taken care of in RT2. Don't feel like you got cheated, because you definitely won't feel like that by the time you get done. First little set of calculations here, geometric unsharpness. Kind of the way to get this all started. Really what you have to realize is we're taking these x-rays, as you read in RT1, you're taking all these x-rays and you know you got to read them, but you got to have something to read, and you know that nothing's perfect. You take a picture with your digital camera, it comes out fuzzy. You take a picture with a gamma ray camera or an x-ray tube, it's going to come out fuzzy as well. So if you can imagine this right here being your piece of film, doesn't matter what kind of film that is, place your part in the middle, okay? Working with geometric unsharpness here, what happens is, since we said it's going to be a little bit fuzzy, the unsharpness factor comes in around the outside of this, where the outside of this image is going to be just a little bit fuzzy. Okay, and you saw that in your RT1 reading, so on and so forth. I draw that all the way around, but that's pointless. Okay, there's a number that you have to follow for this unsharpness or fuzziness. That number is 020, or 20 thousandths of an inch. Okay, if we get outside of that 20 thousandths of an inch fuzziness on the outside edge of this part, you got kind of an issue. You need to reshoot it, need to do something different, kind of make things happen a little bit better. So if you imagine either an x-ray tube or a gamma ray camera here, kind of a brief description would be x-ray tube, okay, got a little window right here, here's a cone of radiation coming out, okay, here's our little electromagnetic waves or x-rays coming out, here's our part laying down here, here's the film that's depicted here, over here, okay, x-rays travel through the part, you get an image of the part on the film, okay, little fuzziness around the outside, that's called geometric unsharpness. This is a calculation you use to figure out how much geometric unsharpness you have. Okay? UG, or geometric unsharpness, equals F, the focal spot size in inches, times the thickness of the part, okay, in inches, divided by the distance from the source in inches. You might not see this as thickness, but that's basically how we're going to use it. It's actually, if you're thinking of, here's the film, here's the top of the part, it's actually the distance from the top of the part to the film. Okay? But some people, just because they're really cool and fancy, will suspend their part in air, so they'll have a gap here between the part and the film. So this thickness value would represent that value there. Okay? Just working number one here, you'll see that on your overall worksheet, or your worksheet 1, or your calculations 1, whatever I've named it there. I forget some of these things. But just working number one. Right there is the equation or the question. It says 0.125 inch source. We have already given a geometric unsharpness value of 0.0029, almost 3 thousandths of an inch, and it's 42 inches from whatever thickness part. So let's kind of just draw that out here. Here's our film. Okay, let's draw a side view as well. We're going to go way up here and say here's our x-ray tube. Okay, there's our cone. This distance here is 42 inches. Okay, kind of hard to see. The size of this source up here is 0.125 inches. We already have a 0.0029 UG, so fuzziness around there, 0.0029. Park that part right on top of the film, it looks like that. Okay, we're going to figure this thickness right here. So let's just do that. Here's our focal spot size. Okay, the size of the source, 0.125. Okay, since everything's in inches, I'm not going to put anything up there. We're looking for the thickness. We don't know it, but we do know that we're 42 inches from that surface, and our geometric unsharpness is 0.0029. So let's work that out here. We got to get T all by himself, so we multiply out 42, multiply out 42. Okay, 42 times 0.0029 equals 0.1218. Now that equals 0.125 times T. Give you a second to kind of take that in. Okay, from there, still trying to get T by himself. Algebra says do one thing over here, you got to do it over here. So we're dividing out 125 over here, dividing out 125 over here. So we take this number, 1218, divide that by 0.125, and you're going to get 0.9744 inches. So this guy says here, 0.125 inch source. We already know that our UG factor is 0.0029. This distance is 42 inches from a part that is 0.974 inches thick. Okay? Relatively easy. Give you a second again just to kind of take that in. I'm going to turn this calculator off because I always lose batteries. So, take that in. Geometric unsharpness, again, just the fuzziness around the edges. Shouldn't be a big deal. If you have questions, feel free to email me. We got quite a few emails going in RT1, no problem there. But please, if you have questions, feel free to email me. But you're going to see that format throughout the rest of these. Okay? I guess one thing I should mention here, as you jump down farther along the questions, you're going to see millimeters mixed in. So if I'm jumping down to like number 5, I'm just going to get rid of this. I'm jumping down to number 5 here. Whoops, that's pretty normal. Number 5 says something to the effect of 1.5 millimeter source. Okay, so on and so forth, 33 inches from